In today's session, we will discuss the VHDL packages and libraries. So what is a package here? So a package contains the common definitions that can be shared across a single VLSI design or across the multiple VHDL designs. So here the package, it contains a common definitions. So the common definitions are nothing but declarations, signal declarations, variable declarations, constant declarations, component declarations, procedures declaration, functions declarations. So here the package is nothing but it is a collection of the shareable signals, constants, types, subtypes, components and the attributes. So simply the package can be viewed as a collection of all these things here. So that is, it can collect a group of types or the subtypes or the subprograms, signals. These are the shareable signals and the shareable variables, and also the shareable constants. So simply here the package is nothing but it is a collection of the types, subtypes, components, procedures, functions, etc. And here the package is a design unit. Actually, to build a digital system using the VHDL, so we will use the design units of the VHDL. So do you remember what are the design units of the VHDL? What are the design units of the VHDL? The design units are entity declaration. So do you remember that? Entity declaration, architecture body, configuration declaration, package declarations, package body. So these are all the design units in the VHDL. So for designing a digital system. Here the package is a design unit that groups the various declarations. As I said that the package is a collection of the declarations, or the package is a collection of definitions. So which can be shared among the several designs here. So here the packages are stored in the libraries here. So this is very important here. So where you can get the packages in the VHDL. So the packages are compiled. The packages are compiled in the libraries. So the packages simply they will be placed in the libraries, or the libraries will refer the packages. So the packages are stored in the libraries. And a package can split into two parts here, the package declaration and package body. Like we have seen in the previous for the subprograms. So we have seen that it has two parts. The procedure has two parts, procedure declaration, procedure body. And for the function also we have seen that the function has two parts, function declaration, function body. Likewise, in the package also, it has two parts, package declaration, package body. So you can understand what is a declaration part and what is a body of the part. So the declaration part always defines, or it considers the name of that package, and also it considers the definitions. The definitions are nothing but here declarations. Okay. And here, as we discussed in the previous point, what is the purpose of the package? Actually, what is a package? Package is a collection of definitions. What are the definitions? Definitions are nothing but group of declarations. So here the purpose of the package is, to declare. So to declare the functions, to declare the procedures, and it can be used to declare the shareable types, subtypes, constants, signals, files, components, and attributes. Okay, so you can declare any of these things using the package. So that is the advantage with the package. Okay, instead of calling, or instead of writing every time, or instead of rewriting the statements every time in the design of the system, so you can group or you can place the functions, procedures, types, subtypes, constants, signals, files and components in a package, and by calling that package you can use all the defined, all the defined functions, procedures, types, subtypes can be used by the user here. So do you understand the purpose of the package? So the packages can be used across the multiple entities, across the multiple designs, so that it avoids the rewriting of the functions, procedures, types, subtypes, and the declaration of the constant signals, and also the declaration of the components. So you can understand that it is a simply the collection of these things. And by declaring these, you can use all these as a single package file in some other entity design. So we will see the another point here. So once a package is defined, it can be used in the multiple independent designs. So just now we stated that. So the package can be used across the multiple entity designs, so that it avoids the rewriting of the functions, procedures, shareable, types, subtypes, constants, etc. Okay. And we will see the syntax of the packages. Actually, the package has two parts. What are the two parts of the package? Package declaration, package body. So what a package declaration defines? The package declaration defines, or the package declaration consists the name of the package. It considers the name of the package, and it considers the package declarations. It just simply considers the name of the package by which we wanted to call the package, and the declarations which we wanted to call by the name of the package. So here in a simple syntax, you can see the package declaration syntax here, where it has a keyword starts with the package followed by the package name is, and then we will declare the package declarations. So what are the package declarations? The package declarations are the function declarations, procedure declarations, types declarations, subtypes declarations, component declarations, signal declarations, constant declarations, variable declarations. And even you can also you can declare in the package. So in a elaborate way, you can see the same syntax in the following way. So the two are the same, the two syntaxes are the same. Okay, the only difference that you observe in the second syntax is declarations. You can see the various declarations. So what declarations you can define in the package declaration? So they are the type, subtype, constant, signal, variable, subprogram, files, and the components, and even the use clause. There are many, and there are so on many are there here. Okay, so this is the syntax of the package declaration, how to declare the package declaration. And second is, we will take an example to this. So what is the syntax of the package? So in the top thing, you can see the package declaration, and here in the below, in the bottom, you can see an example to the package here. So how to declare the package? First, we have to declare the package with the package declaration. So see this example. So package with the package name. So in this example, we take some identifier, user identifier utilities is, and after starting the package with the package name, so then we have to declare the, or we have to define the declarations. We have to define the declarations. In this example, we have declared three declarations here. What are they? The first declaration, if you see, the object is size, and the type of the object is a constant, and the data type is positive. So do you remember what is a positive and what is a natural? In the integer, we have two subtypes. In the integer data type, we have two subtypes. The first is the natural and the second is the positive. So what is the difference between the positive and natural is, natural, it starts from the 0 to the highest range value. Whereas the positive, it starts from the 1. It starts from the 1 to the highest range of the integer value. So in this example, in the package declaration example, we are declaring the size. The size is the constant type and it is the data type of the positive. And see the second one, subtype. So here the vector 8, VGC, vector 8 is a object name. So this object name is a type of the subtype, and which is the type of the standard logic vector. So now the vector 8, this object is the type of the standard logic vector, where the vector is in the descending order, where the vector is in the descending order. It starts from the highest value and it goes to the lowest value. And then see another declaration that you can see from this example, that parity. So the parity is the type of function. It is a function. In the first, size is the constant, vector 8 is a subtype, and the parity is the function. So what is a function? A function is a subprogram which returns a specific type of value. So here we are declaring the parity is a function, and the variables, I mean that the parameters of the parity are the V. V is an object and it is the type of vector 8. So what is vector 8? Vector 8 is a subtype of the standard logic vector 7 down to 0. What is vector 8? What is vector 8? It is the subtype of which one? The subtype of standard logic vector 7 down to 0. So now what this V says now here? The V says here it is a vector signal 7 down to 0. It is a standard logic vector 7 down to 0. And every function must be returned with a type of value. It must be returned with a specific type of value. So in this example, we are taking the type of value is standard logic. So there is a difference between the standard logic vector and standard logic. Standard logic refers either 0 or 1, only two values. Standard logic vector means it is a one-dimensional array. There are 8 elements in this example, 7 to 0. Okay, and the final one is end utilities, which is nothing but the end package with the package name. End package with the package name. You can also mention, it is an optional, you can mention it as end package utilities, or you can directly specify end utilities because the end refers the package name. So this is a simple example how to declare the package declarations for a package, right? So you understand this? It is a simple one. You can define any type of declarations. You can declare the constant, you can declare a constant, you can declare a signal, you can declare variables, also types, subtypes, subprograms. Subprograms means procedures and functions. You can also declare the files, you can declare the components and use clauses also. Okay, so this is an example to the package declaration. What is the second part of the package? The second part of the package is package body. Package body. So we will see about the package body here. So what a package body consists? What a package body consists? The package body defines or it consists the bodies of the subprograms. Whatever the declarations you have declared in the package declaration, in the previously you have declared the subprograms, you have declared the signals or maybe of variables or maybe of function. So now you have to declare those bodies of the subprograms or the signals or the variables in the package body. So we will declare them in the package body. And it is another flexibility is that you can also declare in the package body also the some of the declarations here. You can define the some declarations here. So each package can have only one body. So multiple package bodies are not allowed here. As far as concerned with the VHDL, an entity can have multiple architectures, isn't it? An entity can have multiple architectures. It must have minimum of one architecture. Even if you see for the package is also is nothing but what? It is a similar to that of the an entity and architecture body, but here it is defining with a name of the package, so that here it groups the different declarations and different definitions. So here the package can have only one body here. See the syntax for the package body. Syntax for the package body, it starts with the keyword package body and with the package name. So whatever the name you have given to the package declaration, the same must be used here in the package name is. And in the package body, what you are writing here, you are writing the bodies of the subprograms, or you are writing the complete constant declarations, or even it is an optional one. So this is an optional one. So furtherly, you can have a nested subprograms here. What do you mean that nested subprograms? You will have a main subprogram, and in that subprogram, you can have the another subprogram. And this in turn, it may consist of the other subprogram here. So which is a nested subprograms. So for such nested subprograms can be declared in the package body. The primary subprogram declaration is in package body. The secondary or the subsequent nested subprogram declarations can be declared in the package body. Okay, so this is the syntax to the package body. So here the package has two parts: package declaration, package body. So it has the separate syntaxes for the package declaration and the package body. So already we have seen an example for the package declaration. So now we will see the package body to that example. So the next one is example we will see. Just a minute. Right. So take an example here. So package body. So this is the syntax to the package body. This is the syntax to the package body, right? Syntax to the package body. So now see what are the definitions we have declared in the package declaration. Just recall that the constant we have declared, isn't it? And we have declared a function, right? Am I right? So in the package declaration, we have declared these two, isn't it? And a subtype. And the subtype of the standard logic vector 7 down to 0, that is assigned to this v value. Okay, so here the constant. So in the package declaration, you have declared or you have defined only the type of the object. And now in the package body, we will define with the constant value. So that's why the constant size is a positive type initialized with a value of 16. An example you take 16. And then the same thing we have declared in the package body. So this one, the function parity V is a vector 8 subtype return with the standard logic is. So now here we will have the body of the function here. Here we will have the body of the function. So one second. Actually the function has the two parts. The function in turn, which consists the two parts, right? The function consists the function declaration, function body. So function declaration ekkada declare cheyali? Package body package declaration lo declare cheyali. Function body ekkada declare cheyali? Package body lo function body ni declare chestunna. సో ఇక్కడ కన్ఫ్యూజ్ అవడానికి ఏం లేదు, డోంట్ గెట్ కన్ఫ్యూజ్. సో ఇక్కడ ఏం చేస్తున్నామంటే మనకి తెలిసింది ఫంక్షన్ ప్రొసీజర్స్కి డిక్లరేషన్స్ బాడీ ఉంది. సో ఫంక్షన్స్ని మనం యూజ్ చేస్తున్నాను కాబట్టి ఎగ్జామ్లో ఇక్కడ ఎగ్జాంపుల్లో సో ఆ ఫంక్షన్కి సంబంధించిన డిక్లరేషన్ అనేది ఎక్కడ డిక్లేర్ చేశాను? ప్యాకేజ్ డిక్లరేషన్లో చేశాను. అంటే సో జస్ట్ వి గో బ్యాక్ టు ది స్లైడ్. Just a second. Right. సో ఇక్కడ మీరు ఏం డిక్లేర్ చేశారు? ప్యాకేజ్ డిక్లరేషన్ డిక్లేర్ చేశారు, రైట్? సో ఈ ప్యాకేజ్ డిక్లరేషన్లో మీరు ఏం చేశారు? ఇక్కడ ఫంక్షన్ని యూజ్ చేసుకుంటున్నారు ప్యాకేజీలో. సో ప్యాకేజీలో ఫంక్షన్ యూజ్ చేసుకుంటున్నాం కాబట్టి మనం ఇక్కడ ఏం చేస్తాము? ఫంక్షన్ డిక్లరేషన్కి సంబంధించిన దాన్ని ప్యాకేజీ డిక్లరేషన్లో డిక్లేర్ చేస్తాం. ఓకేనా? ఇప్పుడు ఈ ఫంక్షన్కి సంబంధించిన బాడీ ఉంటుంది కదా, ఆ బాడీ ఎక్కడ డిఫైన్ చేయాలి? ప్యాకేజీ బాడీలో డిఫైన్ చేయాలి. అందుకనే మనము ప్యాకేజీ బాడీలో తీసుకున్న ఎగ్జాంపుల్లో అక్కడ మనం స్టేట్మెంట్స్ని డిఫైన్ చేస్తున్నాం. సో వీ విల్ గో టు దట్ స్లైడ్. రైట్. See, so the function body, this is all function body here to till this point, from this to this, it is function body. And let us see what this function do here is the function parity is a vector type. It is and this function returns a value of standard logic value, which means that either 1 or 0. It returns a value of standard logic, either 1 or 0. So now what are the statements inside of the function? Now we will see here. So here we are declaring the variable. We are declaring the variable B, and which is a type of standard logic with a initial value of 0, right? And then we are start executing we are start writing our actual function of the function. I mean that the operation of the function. So now see here, you are using an integer and you are using a for loop. Here we are using the for loop. It is a sequential statement. So for I in V range loop, for I in V range loop. What is a V here? What is a V range? The V range starts from the vector 8 subtype. So what is a vector 8? It is a subtype of the 7 down to 0, right? 7 down to 0. And ఇప్పుడు ఎన్ని values ఉన్నాయి V range ki? 8 values ఉన్నాయి. What are the values of V here? The values of V are now V of 0, V of 1, V of 2, V of 3, and so on to V of 7. Totally now 8. Here we have defined it as a one-dimensional array. And here you are taking the individual value here. You are taking the individual value. So from that one-dimensional array, you are taking the individual element to out. You are taking the individual element to outside. So here we are using the for loop. So for in V range loop, so where the variable b is initialized with a value of 0, isn't it? So where the b is a variable which is the standard type logic with a initial value of 0. So now what is the value of initial value of 0? What is the initial value of the b? It is 0, and that value is XORed with the vi. So what is the vi? The vi is the I in range of the v range. The v range starts from the v0 to v7. So now it takes the first value of the v0 from the array. And let's say the value of the array v0 is a 1. Example, say 1. So now it performs the exclusive OR operation between the 0 and 1. So the exclusive OR operation results in logic 1, right? Logic 1. So now this loop will be repeated for how many number of times? So this will be repeated for v range number of times. What is a v range? It is a 7 down to 0. So therefore 8 times the loop will be repeated, and finally it will come out after the 8th time it is executed. After 8th time it is executed, it will come out from the loop and it returns the value of the b. So now what you are doing here, exactly what this function does here, it is performing a function of even parity and odd parity of the vector. So how to determine the even parity and odd parity of the vector? So we will perform the logic exclusive OR operation. మీరు ఒకసారి గుర్తు తెచ్చుకుంటే parity generator అనే సర్క్యూట్ మీరు STLD సర్క్యూట్లో చూశారు, గుర్తుందా? సో దాంట్లో ఏం చేస్తున్నారు, ఒక దాని అవుట్పుట్ రెండో దానికి ఇన్పుట్ కింద ఇచ్చి, ఒక ఇన్పుట్ ఏం చేస్తున్నాము మనం డేటా ఇన్పుట్స్ని ఇస్తున్నాం, అవునా కదా? సో ది ఎక్స్క్లూజివ్ OR operation, it determines the parity of that given data, whether it may be of even parity or maybe of the odd parity here. So simply in this package example, we have taken an example of the parity generator. How to perform how we can perform the parity generation operation. So in this we have taken an example, this one. So this is about the package of the VHDL, and as I said that the packages are the collection of the definitions. Packages are the collection of the definitions. So what are the definitions? The definitions are nothing but declarations. So what are the declarations? There are different types of the declarations: signal, variable, constant, file, type, subtype, right? Components. So there are different types of declarations are there, procedures, functions, right? So the package is the collection of the declarations. So now the package, it can be called in a multiple entities, or in the multiple entities it can be called by using the clauses here. We will use the clauses. The clauses are the libraries: library clause, use clause. So library clause, use clause, library clause and use clause. So before we see that library, you can also see another example regarding the packages. So in this example you see, so you can see the package declaration. So from this to this point, it is a package declaration. What are the what definitions you have declared in this? You have declared a type, you have declared a component, you have declared a function, and you have declared a constant. నేను అన్నది అర్థమవుతుంది కదా? ఇక్కడ మీరు సెకండ్ ఎగ్జాంపుల్ అబ్జర్వ్ చేస్తే ఇందులో ప్యాకేజీ డిక్లరేషన్ చూడొచ్చు, యాజ్ వెల్ యాజ్ ప్యాకేజ్ బాడీ కూడా మీరు చూడొచ్చు. ప్యాకేజ్ డిక్లరేషన్స్ లో ఏముంటాయని చెప్తున్నాం మనం? ప్యాకేజ్ డిక్లరేషన్స్ లో మనం డెఫినిషన్స్ ని ఇవ్వచ్చు. యూ కెన్ డిఫైన్ ది డిక్లరేషన్స్. సో ఇన్ దిస్ సెకండ్ ఎగ్జాంపుల్ వీ హ్యావ్ డిక్లేర్డ్ ఎ కాన్స్టాంట్, వీ హ్యావ్ డిక్లేర్డ్ ఎ టైప్, we have declared a component, we have declared a function. So we have declared 4 definitions here. And see the package body. So this is package body here. So this one is package body, this one. So in this package body, exclusively, we have seen only the function here. We are not seeing the constant, type and component, because the moment we are not using those, and you are taking the function, and in this function, ఎవరు unmute అయినట్టున్నారు? Right. So in this package body, so we are using the function here. అంటే ఇక్కడ మీరు ఒకటి అబ్జర్వ్ చేయండి, ఇక్కడ మనం డిఫరెంట్ డిక్లరేషన్స్ డిఫైన్ చేస్తున్నాం, కానీ అన్ని యూజ్ చేయాలని అవసరం లేదు కదా. ఇట్ ఈస్ నాట్ కంపల్సరీ టు యూజ్ ఆల్ ద డిక్లేర్డ్ డెఫినిషన్స్ హియర్, రైట్? సో విచ్ ఎవర్ వీ వాంట్, సో ద పర్టిక్యులర్ థింగ్ కెన్ బి యూజ్ ఇన్ ది body of the packages here. So kabatti ikkada mana example ki, in order to understand this, so we are taking a function bitwise. So it is a bitwise AND. The function name is bitwise function, bitwise AND. So the function here, it performs the bitwise AND operation. So you can call this function in some other entity design by using this package. So what this bitwise AND function does here, so it performs the bitwise AND operation for the given data. So what is the size of the data? The size of the data is 4-bit, 3 down to 0. It is a type of the standard logic vector, and the size is 3 down to 0, which is a 4-bit. So for the given 4-bit number 1010, say an example. So now it will do the bitwise AND operation, and finally it returns a single value. It returns a single value. And what is that value here? Standard logic. ఇక్కడ చూడండి, ఈ ఎగ్జాంపుల్ మనం ఏం తీసుకుంటున్నాం? స్టాండర్డ్ లాజిక్ వాల్యూ, రిటర్న్ స్టాండర్డ్ లాజిక్. సో ఆఫ్టర్ పెర్ఫార్మింగ్ a bitwise of AND operation with each bit in the given data, finally it returns a single bit of result, either 0 or 1. So that is the bitwise AND function in this example. So in the exam point of view, or in the exams, so take a simple examples. Simple ante mari ఒకటి రెండు instructions ఉన్నాయి కాదు. It must be a moderate example. Okay, so oka 1 or 2 examples మీరు explain చేయగలిగితే, explanation అంటే in the sense you will give you can give the syntaxes of the declaration and package body, and then by taking an example you can explain that functionality. So that is more than enough for a packages of the VHDL. Okay, టెక్స్ట్ బుక్లో ఒక్కొక్క టెక్స్ట్ బుక్లో ఒకలా ఉంటుంది, మీరు ఏదైనా రిఫరెన్స్ తీసుకోండి. బట్ ద థింగ్ ఏంటంటే, రిమెంబర్ దట్ ఆల్వేస్ యూ హ్యావ్ టు రైట్ you have to give the syntaxes first, and then give an example and then explain it. Okay, చాలా మంది ఏంటంటే డైరెక్ట్గా ఎగ్జాంపుల్కి వెళ్ళిపోతారు. Even in the assignment submission also I have seen that. So some of you have directly gone to the example here. దీనివల్ల వచ్చే నష్టం ఏంటంటే, మీరు ఎక్స్పెక్ట్ చేసే మార్క్స్ ఇక్కడ రావు. ఫర్ ఎగ్జాంపుల్ ఒక 8 మార్క్స్ క్వశ్చన్కి మీరు ఎక్స్పెక్ట్ చేస్తారు 6 మార్క్స్ అని, కానీ ఇక్కడ మీరు డైరెక్ట్గా ప్యాకేజ్ అంటే ఏంటో చెప్పేసి సింటాక్స్ లేకుండా డైరెక్ట్గా ఎగ్జాంపుల్కి వెళ్ళిపోయారు అనుకోండి, you will get a 4 marks, 50% of the marks you can score it. But if you want to get an 80 or 90% of the marks, so you must be given with the syntax. So syntax undali, syntax tarvata example తీసుకోవాలి, example ని explain చేయండి. ఏం చేస్తుంది ఆ ఫంక్షన్, ఏం చేస్తుంది అని చెప్తే సరిపోతుంది. ఓకే, సో రిమెంబర్ దట్ సబ్మిట్ చేసిన వాళ్ళు సబ్మిట్ చేశారు, బట్ ఎగ్జామ్ పాయింట్ ఆఫ్ వ్యూలో నేను చెప్తున్నాను, ఈ పాయింట్ మీ అందరూ తీసుకోండి. నాట్ ఓన్లీ ఫర్ దిస్ వన్, whatever so far, whatever we have discussed, for all that we have syntaxes. So take syntax, write an example and explain it. Okay, remember that even in the exam also. Okay, so this is about the packages, and the another one is libraries here, and another one is libraries here. One second. And another one is libraries. Now, what are the libraries here? The libraries are nothing but the collection of the packages here. Okay, it is nothing but in a hierarchy. It is nothing but in a hierarchy. మనం ఒక హైరార్చీని చూస్తున్నాం మీరు ఇక్కడ అబ్జర్వ్ చేస్తే. ఎట్లాగా మనం ఫస్ట్ టైప్స్, ఆబ్జెక్ట్స్, ప్రొసీజర్స్, ఫంక్షన్స్ డిస్కస్ చేసాం. వీటన్నిటిని కలిపి ఏం చేసాము? ప్యాకేజ్ రిప్రజెంట్ చేస్తుందని చెప్తున్నాను. ప్యాకేజ్ ఏం చెప్తుంది? Will be represented by the libraries antunam. So now what are the libraries? Libraries are the collection of the packages. It is nothing but a combination, or it is a group of packages here. So here a library, class, the library is referred with a class in the VHDL. A library class defines the logical names for the design libraries in the host environment. In the VHDL software, so we will have the libraries here. The libraries refers the packages. Packages refers the definitions. Definitions refers the declarations. Declarations are the object declarations, data type declarations, or subprograms or component declarations. Okay. So a library clause defines the logical names for the design libraries in the host environment. And here the logical names of the design libraries which are used by the design units here. They are used by the design units. What are the design units? The design units are nothing but entity, architecture, packages, configurations. So the libraries refers the design units. అంటే ఇక్కడ ఇంకొకలాగా ఎలా అర్థం చేసుకోవచ్చు మనం? They are nothing but the combination, they are the collection of the, or the group of the packages here. Group of the packages. And here the VHDL libraries allow you to store commonly used packages. So that's what we have stated in the previous one. So the libraries are nothing but what? They are the collection of the packages. They are the group of the packages. And here there are two predefined libraries are there. The two predefined libraries are standard library, work library. Standard library, work library. In VHDL we have two predefined libraries. One is standard library and other one is work library. So here the standard library contains the standard packages which are all inbuilt. They are all predefined in the VHDL software. Standard libraries. Example to a standard library is IEEE 1164. Library 1164. I mean standard logic 1164. And the second one is work library. The work library is a working library where all user created and analyzed design units are stored. The user defined packages are referred with the work class. It is referred with the work class. So we have the library class. There are two types of the library clauses: standard library class, work library class. The standard library class is which contains or which consists the packages, standard packages here. Where the working library, it consists all the user defined packages, all the user defined entities. Okay, so there are two types of the libraries in VHDL, standard and work. So here we will see the syntaxes for the library used for the two types. One is standard library class, second is user class. I mean that the work class. So it is a simple statement: library with the library name. Library with the library name. So the standard libraries in the VHDL are called by their library name. Example, you can see here in the below. Example here you can see a library IEEE. So which means that you wanted to use this IEEE library for your designing of the digital system. And in that library, if you want to use any of the particular package, if you want to use any of the particular package, that will be called by the use class. That will be called by the use class here. So that's why an example you take, IEEE is the standard library. So for this IEEE library, we have different packages in the IEEE. Okay, signed, unsigned, IEEE standard logic signed, IEEE standard logic unsigned, IEEE standard logic numeric, IEEE standard logic arithmetic. There are different IEEE packages in the library of IEEE. So you can particularly call, or you can use particularly a package by using this use clause here, by using this use clause. So from this IEEE, we want to use the standard logic 1164 package. So use, name that IEEE std logic with dot all. So what does this dot all says here? Which means that you can utilize, you can use all the packages things in from this standard logic 1164, or else you can also choose a particularly thing from this package also. Okay, so here this is the use class here. This is the use class. So just now we seen this example here. So use library name, package name, dot item name. అంటే ఇక్కడ ఏం చేస్తున్నాము, ఏ లైబ్రరీ వాడాలనుకుంటున్నామో ఆ నేమ్ దేంతో స్పెసిఫై చేస్తున్నాం, లైబ్రరీ క్లాస్తో. ఆ లైబ్రరీలో ఏ ప్యాకేజ్ యూజ్ చేసుకోవాలి అంటే ఎట్లా మనం యూజ్ చేస్తున్నాం, యూజ్ అనే క్లాజ్ వీఆర్ యూజింగ్. సో యూజ్ IEEE dot package name. What is the package name? Standard logic 1164 dot item. So we wanted to use all the items, or we wanted to use all the things in the std logic 1164. So that I am using the dot all. If you don't want the all, so then you can use the particular item name. With that particular item name, you can use in your entity here. And how to use the work library? How to use the work library? So here we will specify the, and here we will use this work library with this statement, use work with the name work dot name of your package, name of your package. In the previous example, we have used this utilis, let's say utilis dot all. So what does it mean here? Use work dot utilis all, which means that we wanted to use the package utilis, and from that we wanted to use all the items from that utilities. So what you have defined in the utilities, you have defined a constant, you have defined a subtype, you have defined a function parity. So those can be used in your entity design. So this is all about the packages, libraries, and the packages of the VHDL. So with this, maximum we have covered the concepts of the VHDL. We have covered the concepts of the VHDL. Okay, so in the next class, we will discuss about the modeling styles of the VHDL. We have 3 types of the modeling styles, as we all know that: behavioral modeling, data flow modeling, structural modeling. So we will see an examples to we will see an examples to the data flow modeling and structural modeling, and after that we will move on to the unit 3, behavioral modeling. Okay, so do you have any questions? Do you have any questions? Do you have any questions?